Hey guys, welcome to Number Sense 2.5, how about the objective over operations with rational numbers that include exponents. We will have some real life situation problems where we do have an order of operation problems that do have an exponent. And I'll zoom in and we'll talk about those at the end. They look pretty intimidating, but I promise you that they are not. And you have a yellow or green paper for your activity. If this is the 2016-17 year, I want you to only cut on the dotted lines here and here when you get ready to put this into your interactive notebook, because I plan on us writing a little bit in the margin here and needing to go all the way to the bottom. So we'll take care of that. Also, be sure to start with getting out your interactive notebook. Okay, and turning to your, that's right, table of contents. We're going to do, for me, page 21, and it is objective over, just put operations, rational numbers plus exponents. And I'm, of course, going to put that it's objective 2.4 in my notebook. Okay, then turn to your right past your exponents page, which was 20, and this is going to be 21. And then when you're done, you can trim out your paper and glue it in. Okay, let's get right to it. In these problems, the focus is on exponents. Look here, this is an unknown. It's the letter Z. It might look like a 2 from your screen, and I do encourage you to go ahead and maximize your video screen to help you. So what this is this, whenever we're dealing with a power of 10, is this number tells me how many zeros I have in my answer, right? So since I have 2 zeros here, then this exponent must be 2, right? So let's look here and see how that goes, okay? So if it has an unknown exponent to the power of 10, I'm going to look at my answer and I'm going to count how many zeros. All right. I'm trying to zoom that up better. Okay? 4 zeros, so it's 10 to the power of 4. Let me remind you that 10 to the power of 1 means I have 1 0, so it's 10. Any number to the power of 0 is equal to 1. Those are just some basic facts, and that would include 10 to the power of 0 is 1. It has 0 zeros. Easy to remember, right? Okay. What about when I have a value that's not a power of 10? This is an unknown. It's a letter Q. It's not a 0. And it's saying how many 3's, when multiplied together, will it take to get to 27? Well, you probably already know this, but I'm going to tell you that you are just going to keep your base times your base continually until you get to the answer. So my base is 3, so I'm just going to do several 3's and see how many it takes to get to 27. Well, 2 of them gives me 9. So let me add another one. Oh, there it is. So how many 3's did it take to get to 27? 3. So 3 cubed is 27. And then here is our first order of operations type problem. In class, at the workshop, we talked about when the exponent only talks to what is directly in front of the exponent. So here, since it's grouped together, you cannot separate the negative and the 2. So it's literally saying -2 3 times and multiply. Well, a negative times a negative times a negative. We have an odd number of negatives. The answer will be negative. 2 times 2 is 4. 4 times 2 is 8. And that would have been negative times a negative is a positive, and a positive times a negative is a negative, if you need me to say it that way. But let's look here. The 3 talks to the 1 and says 1 times itself 3 times. And we do that first because we do exponents before anything else, well, except for parentheses. minus negative 6. Of course, 1 times 1 times 1 is 1. Keep, flip, change. 1 plus 6 is 7. Very good. And then look at the difference here. The numbers are switched. Let's see how much it makes a difference. My 2 is talking to the negative and to the 3 because they're being grouped together. And so I have negative 3 times negative 3 minus 3. Remember, we do this first because we're performing our operations with exponents. Negative 3 times negative 3, positive 9 minus 3. 9 minus 3, simply 6. If you need to, you could say keep, flip, change, bigger number on top, write down your symbols, signs are different, subtract, keep the sign with bigger number, but pretty much 9 minus 3 has been 6 in second grade. Let's look here. The difference between the exponent here and the exponent in this situation is that there's not a pair of parentheses there. So the 2 only talking to us directly in front is only talking to the base 2. This negative stays outside. Then this is 2 times 2. Okay? Writing the rest of the problem. 2 times 2 is 4. That negative is still there. Now what? That's right, left to right. Negative 4 times negative 5. And 20 times 6. 120. Okay. Now, the 1/3, is it talking to the negative and the exponent 3, is it speaking to both the negative and the 1/2? No, it is speaking only to the 1/2. So the negative stays out here by itself, and this becomes 1/2 times 1/2 times 1/2. And we'll do that operation before we would subtract or multiply this negative into it. So the negative stays out. 1/2 times 1/2 times 1/2 is 1 plus 2 times 2 times 2. Do you remember? That's right, it's 8. So I have negative 1/8 now minus 3.125. So if you remember when we worked with our regular operations with rational numbers, what do you do when you have to add or subtract? The values are different. I have fractions and decimal form. I hope you remembered we're going to convert this into a decimal. So you're allowed to use the blue calculators, and I'm going to change 1/8 to a decimal. Do you remember how to do that? I hope so. 1 divided by 8. Oops, I'll try that again. 1 divided by 8. 0.125. So this is negative. This is 0.125 minus 3.125. I've got a subtraction problem and I need it to be an add problem. That's right. Additive inverse. Keep, flip, change. Bigger absolute value on top. Finish writing the signs. Compare the signs and see that they're the same. So I'm going to add my values and keep the sign of the bigger number. That's correct. Final answer here is negative 3 1/4. I don't need that 0 on the end. It's not wrong if I left it there. The best answer is we don't record it down. Okay, so that one was quite a bit more complicated and definitely something that you should anticipate seeing on your quiz. Let's look at a real life situation where we have order of operations with exponents. So in this situation, Shannon has $300 in a savings account. Maybe this is money she's accumulated from birthdays and Christmases, and she's been encouraged to put in a savings account. The interest rate on the savings account is 11% compounded annually. You know you're in 7th grade. You probably don't know exactly what that means. So let me just say that basically if you give your money to a bank to keep in a savings account, then they will give you a return on that. They'll give you a little bit more than the $300 when you're ready to pull it out if you've left it for a while. And they'll give you this interest figured on years worth of them having your account. So the question says, to the nearest cent, how much interest will she earn in a year? Thankfully, we're given a formula. And it says, use the formula. Now, you guys have not had to use formulas so much this year. So let me tell you, when you use a formula, it's actually the easiest thing and kind of the funnest thing as you get into more difficult and higher level maths. And one of my friends just called it a plug and chug. So you will just start by writing the formula out again. Oops. Okay, start, and then bring down a whole bunch of equal signs. Okay, then we're going to plug in values, but you have to know what these things mean. B is the balance or the final amount. Let's come up here and let's give ourselves a little note here that the balance is the final amount. Okay, that's usually what you're solving for, hence why they have that here. That's equal to P. P is the principal. No, we're not talking about Mr. Layton. We're talking about the money you start with. So in our problem, how much did we start with? That's right, $300. So under here, we'll plug in what P is. In our problem, it's $300. Then, this is a 1 plus our rate. Well, what is a rate? Our rate is our interest. And it needs to be in decimal form. It's usually given to us in a percent. So let's remember, 11%, if we Dr. Pepper that, becomes 0.11. So for R, let's put 11%. And then finally, our time. That's what the little t is right here, and that is the number of years. So the question is, how much interest will she earn in 1 year? So where my t is, I'm just going to put a 1. So then we're going to solve. PEMDAS tells us to do the parentheses first. You probably do not need a calculator, but you can use one to say 1 plus 0.11 equals, yep, 111. So 300 times 1.11 to the 1 power. Well, what is 1.11 to the first power? That's right, just 1.11. So this would be 300 times 1.11. Well, here's my calculator. I already have the 1.11 on there. So times 300. What do you get? You might want to pause the video and see if you can get the right answer and then check it with mine. Here we go. $311? No. Let's try that again. 300 times, not plus, 1.11. There we go. $333. I could tell right away when I got $301.11 that I had pushed the plus button. I wonder how many of you caught that when I did it. Okay, so basically, if I start with $300 and I leave it for 1 year at 11% interest, at the end of the year, my balance or my final amount is $333. But the question was, how much interest, that means extra money, did I earn? Well, if I have 333 is my balance, and I started with 300 and I take that beginning principal away, how much did I earn? That's right, I earned $33. So maybe that seemed like a lot. So we're going to practice one more problem. Let's start by writing our formula. It stays the same. Our balance plus our principal amount times 1 plus the rate with time as our exponent. And I'm going to bring down my parentheses here. My principal here, if she keeps it in her account, oh, I guess it's still $300. For 2 years, so my time is going to be 2 at 7% interest. So my rate is 0.07 because 7% is equal to 0.07. How much will she earn? Well, 300 times, what is 1 plus 0.07? I look at this as $1 plus 7 cents, so it would be $1.07. But now my exponent's a 2. So I'm going to use my calculator and say 1.07 times 1.07 equals, look at that. That's a big number. That's 1 and 1,449 10,000ths. Now we'll just say that this number becomes 300 times 1.1449. Take that times $300, and at the end we have $343.47. I'm sure you can tell just by looking. How much did she earn in interest? Remember, she started with 300. So 343.47 minus the 300 she started with. Yep. She earned 43.47. She had to leave it there twice as long. She had to leave it for 2 years. And she learned less interest rate at only 7%. She ended up with a little bit more. Okay, I encourage you to practice these problems on IXL. All right? And hey, by the way, guess what fingernail grows the fastest? The middle one. All right, have a good day.